This video is on factoring trinomials, and we're going to start simple. We're going to start where the leading coefficient is 1. Let's talk about what that even means. Many trinomials factor into a product of binomials, and typically when we're talking about our trinomials, they're in this form: ax squared plus bx plus c. Remember, this is in descending order from the highest degreed term. It also gives us the degree of the polynomial, which in this case is 2. A, B, and C in all of these cases are just coefficients where C is a constant. It doesn't have a variable on it. This we call the quadratic term when the degree is 2, because what we're going to learn is that quadratics have a degree of 2. Here we have a linear term. If you recall from graphing lines, a linear term, the highest power is 1. And then we have our constant term. So you're going to hear me refer to these in these names. When we have something in descending order, we call this our leading term. And therefore, the coefficient on that term is the leading coefficient. In this particular case, it's A. And so we're going to start by factoring trinomials where A equals 1. Now, we can use distribution or FOIL to kind of help us see where this product comes from. And let's look at a couple of examples here. If I were to distribute this product of binomials using FOIL, first, outsides, insides, last, I get for my firsts x squared. My outsides are x times 4, which is 4x. My insides are 2 times x, which is 2x. And my lasts would be 2 times 4, which is 8. So combining like terms, my insides and outsides are going to be alike because there's an x in both of the first positions. And 4x plus 2x is 6x. So when I write this out as a trinomial, I have x squared plus 6x plus 8, where the leading coefficient is, of course, 1. And I have a trinomial that is in descending order. Well, let's think about where all these pieces came from. The x squared came from the product of the things that are in the first position. The 8 came from the product of the things that are in the last position. And really, that's what creates the binomial. Well, you might ask, okay, then where does this 6x come from? Well, that is a product, the sum of the products of the outsides and the insides, which are created because when we FOIL or distribute, we have to distribute all of the terms in the first group to all of the terms in the second group. And so that's then where this middle term comes from. It's from the sum of the blue times the green in the outsides and in the insides. Let's look at another example that's a little bit more ambiguous. And here I have x plus a and x plus b. If I were to FOIL this out, for my firsts, I get x times x, which is x squared. My outsides is x times b. And I'm going to write that as bx. My insides, which is a times x, I'm going to write that as ax. And my lasts is a times b. If I were to write this as a trinomial, I would have x squared, and then here I'm going to consider those like terms. They both have an x in it, and a and b actually will be numbers. And so what I'm going to do is I'm going to put plus b plus a x, so that you can kind of see that eventually what I would have done to add my like terms is add those coefficients together. Then I've got plus a b. And so what this does is it kind of helps you see where these two pieces come into play in the trinomial. I'm going to have the sum of AB create my middle term, and I'm going to have the product of AB create my last term. Now this is going to change a little bit when we factor trinomials where A is something other than 1, but this is going to help us just to kind of understand where all the pieces come from. All right, let's just start with basics. The first thing we will always do is pull out a GCF. We're always going to check for that first. That reveals so much to us and helps us create more simple numbers if we need to. So GCF is always going to be first. Then we would check our special factor patterns. We would check for difference of two perfect squares. We would check for perfect square trinomials because those are pretty easy to factor. The next thing that we would do is put it in descending order. In all of these cases, the leading coefficient is going to be 1, and so we're going to descend from the highest variable term, or the highest degreed term. In this particular case, that would be y squared plus 5y plus 4. It's already in descending order. So now, when I'm factoring this, I'm going to look at the factors of 4 in order to see what set can add to make a 5 at the same time multiplying to make a 4. Whenever I'm finding the factors of a number, I always want to start with 1 in itself, and then I want to go in consecutive order of integers and test them all until I repeat to make sure I have them all. And so the factors that can create a 4 are 1 and 4 and 2 and 2. Now I need to know which set of these can add or subtract to create the 5, because I know that when I FOIL this out, my outsides and my insides are going to sum to create this middle term. 1 and 4 can create the 5. And so I'm going to say, okay, now what kind of 5 am I making? Well, it's a positive 5. That had to have been a positive 1 and a positive 4 in order to make that 5. The other thing that I need to test and make sure is that does positive 1 times positive 4 create a positive 4? And that's true too. So this had to have been a 1 and a 4. The cool thing about this is because the leading coefficient is 1, it doesn't matter whether it was y plus 4 first and then y times 1 or the other way around. They both say the same thing. It's just commuted. And so there's my answer. Let's look at some sign patterns that can help us. If I have a positive constant term, here, then that means that the only things that can create a positive constant term are multiplying two positive numbers together or multiplying two negative numbers together. You know which one you need based on the sign of the middle term. If this middle term is positive, I had to add two positive numbers together to get it. So then in this pattern, the binomials both have to have plus signs because I multiply two positive numbers to make a positive, and I can add two positive numbers to make a positive. If this middle term is negative, they both had to be negative signs because I can multiply two negatives together to make a positive, and I add two negatives together to make the negative. So if you have a positive constant term, your signs have to be the same. They're either both positive or they're both negative. Let's look at this one. Here, my constant term is negative. The only way that could happen is if one sign was positive and one sign was negative. The same thing's true no matter whether the middle term is negative or if the middle term is positive. Then we just need to check to see which one has the bigger factor, because if it's a negative middle term, the bigger factor had to be negative. If it's a positive middle term, the bigger factor had to be positive. Let's look at a couple of examples. In the first example, I have y squared minus 7y plus 12. I'm going to find all the factors of 12, starting with 1 in itself, that's 1 and 12, 2 and 6, 3 and 4, and I need to find the set that can add or subtract to make a 7. The only set that does that is the 3 and the 4. Because this was a positive 12, I know that both of these signs had to be the same thing. And since I'm creating a negative 7, they're both negative. That leaves me with y minus 3 times y minus 4. You can easily FOIL that out to double check. Let's look at the second example. I have a squared plus 2a minus 15. Factors of 15 are 1 and 15. 3 and 5. That's all that I've got there. I know I had to add or subtract to create a positive 2. And since this sign is negative, the signs had to have been different. And since I'm making a positive 2, It should have been a positive 5 and a negative 3. So that would leave me with a minus 3 times a plus 5. Again, you can pause, FOIL that out really quickly, and check to make sure that we have the right thing. Last example is z squared minus 4z minus 21. And here I have 1 and 21, 3 and 7, and I need to make a 4z. In order to make a negative 4z, that had to have been negative 7 and positive 3, which also works out because negative 7 times positive 3 is negative 21, which is what I have here. And so it factors to x plus 3 times x minus 7. Okay, let's look at this example that has some GCFs. How many terms do I start with? I'm starting with 3 terms, and I need to pull out GCFs, and I even have a red flag maybe here. I'm going to go ahead and pull out a negative and then look for the coefficient GCFs and variable GCFs. In this particular example, I have a negative 3a. That is in common for all of them. That leaves me with x squared minus 3 plus 2x. Then I need to put it in descending order so that I can factor it. That would be x squared plus 2x minus 3. Remember, pulling out that negative changes the signs on all the terms initially. Now I'm going to find all the factors of 3 because my leading coefficient is 1. 1 and 3, that's my only set. They're going to add or subtract to make a positive 2, which means this had to be positive 3 and negative 1. I double check to make sure that positive 3 times negative 1 is indeed negative 3. That is true. Don't forget your GCF out front, and this factors to x minus 1 times x plus 3. See if you can do this very last example on your own. Pause now. All right, this one should be pretty simple. The only factors of 3 are 1 and 3, and I'm creating a positive 2. So that would be a positive 3 and negative 1. That's the only way to do it. But what I need to double check is positive 3 times negative 1 a positive 3? It's not. So what ends up happening with this particular example is it's not factorable. It's prime. There's no way for me to create a binomial times a binomial and get these exact values. That means that you always have to check. You always need to check your signs. You never give up, but if something doesn't work out, it's okay. It's prime. We'll talk about this more in class.